Okay, hi everyone. So in this video, I'm going to go ahead and talk about two really key pieces of evidence that help support the Big Bang Theory. Now, there's lots of other details we can go into, but these are kind of the two big ideas we're going to go ahead and talk about for this class. Okay, so the first piece of evidence is redshift. And redshift is important because it lets us know that the universe is expanding and is still continuing to expand even going into the future. So this comes down to the idea that colors are not what they always appear to be. So if an object is moving really, really super fast, so we're talking over 3,000 kilometers per second, so really, really fast, the color of light can actually appear to shift slightly to different wavelengths. So we can move it either to the right or to the left, so shorter or longer wavelengths. Okay, so if an object is moving away from us, it appears to have longer wavelengths. So you can kind of think of a slinky stretching. As you lengthen it as it goes away, it's going to get longer time between each of those little bumps. So this creates what is known as a redshift and makes the spectrograph of the object move towards the red side of the color spectrum. And it's just slightly, it's not a huge change, but a little bit to the red side. If an object moves towards us, it will appear to have shortly if an object is moving toward us, it will appear to have slightly shorter wavelengths. This is like if you take a slinky and you push it together. So this creates a blue shift and causes a spectrogram of the object to move towards the blue side of the color spectrum. So when scientists view spectrographs of distant galaxies, they find the light is redshifted, meaning that the objects are moving away from us. And they're also moving away at a really fast pace, because remember, redshifting only occurs if the object is moving at least 3,000 kilometers per second. Now, it's also important to know that galaxies that are further away from us have larger red shifts. This means that those really distant galaxies are moving away and spreading out faster than the galaxies that are close to us. Okay, so the second evidence we have for the Big Bang Theory is cosmic background radiation, oftentimes abbreviated CBR. So cosmic background radiation lets us know that the universe used to be really, really hot. Okay, and this comes from outer space in the form of microwaves. Now, we can't see these with our eyes, but we can detect them using radio telescopes. And also, if you have one of those really old-fashioned TVs, probably like one that your parents grew up with, that static that's kind of in the background, if they're not tuned on to a channel, that is actually cosmic background radiation hitting the television antenna. So we are having this around us at all points in time. It's fine. We don't get harmed by it, but we can't see it unless we have the right tools. So this radiation is really important as it comes in the form of photons, which lets us know about where it came from. Okay, so it carries information where its origin was. And it also is helpful because it tells us the temperature of outer space, specifically that it's 2.725 Kelvin in outer space. Now, this isn't a huge number, but it had to come from somewhere. We have nothing in our recorded history as humans that tells us where this heat would come from, so we know it comes from a really, really long time ago. And because we know it comes from a really, really long time ago, that heat, since it still exists and is measurable, means the universe must be really hot, which, if you think back to the Big Bang Theory, everything started as that really, really hot mass, that tiny little time space energy, before it started to spread out. So overall, those two things, redshifting and cosmic background radiation, help to support the theory of Big Bang. Okay, so thanks for watching, everyone. If you have any questions, please let me know.